triangles, aka the sexiest shape in existence. I'm just kidding. Or am I? I'm never wrong. So triangles are one of, well, they're basic geometry. If you don't know what a triangle is, then look it up. Google is free. But anyways, so triangles are very interesting. So today we're going to talk about trigonometry, aka my favorite unit of math, because I'm a nerd. Well, also it's actually really easy, so stay tuned. So let's start off with the basics of triangles. A triangle is a three-sided shape, 1, 2, and 3. So there are, all of the angles in a triangle always add up to 180, no matter what triangle you draw. So technically this one, all of them add up to 180. So let's say, there are three types of main types of triangles that are basic knowledge. So there's the equilateral, the scalene, and if I do this right, the isosceles. So all of these are pretty basic. Hold on. I don't think you can see this one, right? I think that's better. But, so all of these are basic triangles. So, what happens here? So the equilateral, it's in the name. All of the sides are equal. So, if I do this, so, pop quiz, what's 180 divided by 3? Well, that is 60. So, all of these angles would be 60 degrees if this was an equilateral triangle. And yeah, all of these, and I think all the sides are also the same length because they're all equal here. So the isosceles, only 2 of the angles are the same. So, let's say these two are 80 and 80. So that adds up to 160. And then this one is 20. So that is an isosceles. And a scalene, all of them are unequal. So I'm kind of lazy, so I'm not going to do the scalene because, you know, I don't really want to. But you get the point. It's pretty straightforward. So, then there is the right angle triangle. So, the right angle triangle. So, a right angle is basically any angle that's 90 degrees. So, what that looks like is this. It's just like the end of a square. It's pretty straightforward. So, that is a right angle, one right angle. So, if you would have a right angle triangle, you guessed it, it would be like this. So, this is 90, and then these two are like whatever the hell you want it to be. So continuing from the right angle triangle stick, so this, as you know, is a right angle triangle. So triangles, so of these types, they follow something called the Pythagorean theorem, or Pythagorean. I have no idea how to pronounce it. I'm just kind of going off a whim here, but however it's pronounced, it applies. So, have you heard of A2 plus B2 equals C2? Well, that is how you find out a missing length. So let's say this is 8, this is 6, and then this is X. So, how you do that? So the formula is A2 plus B2 equals C2. So this is A. So let's say this is A. So 8 squared is 64. So 64 plus, and 6 squared is 36. 36 equals, so now let's do the math. So it's like 100. Yeah, that's 100. So this isn't the side length. One, it's much too small to be 100 units in length. So 100 is not our answer. So we need to find the square root of 100. So 100 squared is 10. So that means that X is equal to 10. Ta-da! So now we're gonna do something called Sokotoa. You might be wondering, well, what the fuck is Sokotoa, man? That sounds genuinely stupid. But it is a very wonderful tool for memorization. So Sokotoa is Toa. So it is Sokotoa. So it translates to sine opposite. I'm just going to write it as op. Hypotenuse. I'm just going to write it as hyp. Cosine. Adjacent. I'm just going to write it as hyp. And tangent. So, you might be thinking, well, what are these things? I don't get it. So, in a right angle triangle, got the right angle. So the side that's opposite the angle right here is the hypotenuse. So then we'll put it as h over here. So that's the hypotenuse. Then what is the opposite and adjacent? So let me give you a hypothetical. Say you're finding this angle. So you don't know what it is. So x. So how you do that is, so the side that's opposite, so this way, would be the opposite. And then the other one would be adjacent. So we've got our values. So, well, what do we do with them? Here's where Sokotoa comes in. So if you want to find x, so I'm going to give these things a few values. So let's say A is 12 and O is, 13. So now you're going to get your handy dandy calculator. So you need a scientific calculator. So let's go through the basics of the scientific calculator. So it's got to have sine, cos, and tan. You'll see it there. And so to find an angle, where's my chalk? Right here. So to find an angle, so if it's 13 and 12, let's think of Sokotoa. So what do we have here? So the hypotenuse, we don't know that value. So we have the opposite and the adjacent. And what does that correlate to? Tangent, or for short, tan, which is right over here on the scientific calculator. So what you do is, so the O comes before the A. So it will be 13 divided by 12. So 10. So you might be thinking, well, what's 10 negative 1? So 10 negative 1. So you're going to look right here. And so you're going to go to second function. So right there. I like to think of it as the second floor. It's like a staircase. So, going to go to second function. And then you're going to click on tan. So then it's going to go to, so second function, tan. And then you'll see tan negative 1. That's how you find tan negative 1. So it's going to be 10 negative 1, 13 divided by 12. So let's do the math here. So 13 divided by 12 is, that's a big number. 1.083333, and probably goes on forever. So if that's 13 divided by 12, so you might be thinking, well, do we times it or do we add it? Well, you don't really times it at all. So once you have your value, you just go to second function, 10 negative 1, and then you press equals. So looky here. It is 47.30. So we round it right there. So this angle is 47.30. 3 degrees. Cool, huh? And using this method, you can solve the entire triangle. You might be wondering, well, so we covered tan negative 1, but so then what's the regular tan used for? Well, friends, that's for finding length. So remember the principles of SOHCAHTOA. Sine, cosine, tan, opposite, adjacent, hypotenuse. So here we have a right angle triangle. So say we already know the this thing is going to be 18, but we want to find A. So how do we do that? So first, we're trying to find A. So, and we already have H, so that would be cosine. So cos. And then let's just say this angle is 20. So cos 20 equals, so then it's going to be A over 18. And then, so we're going to put a phantom 1 right here. So I'm just going to put it like that, so you know that it isn't really. So we do some cross multiplication. So that means that A is going to equal cos 20 times 18. Or you can just put the 18 in brackets. This just makes it look more confusing. So I'm sorry for that. But let's put out for a handy dandy calculator. Cos 20 times 18, which is going to be 16.91, which we can add up to 17. So A is going to equal 17 unit length. So that's what tan and, the regular ones are used for length. So to finish off, let's talk about angles of inclination and depression. I'm not going to be going too far into these, but here's what they are. So this one above, right here, I'm going to put a line. So this one, the arrow, is an angle of inclination. So as you can see, it starts here and it goes up. So up. And then this is an angle of depression. This one, right down here, starts here, goes down. Pretty simple. Anyways, that concludes trigonometry part 1. So have a good day. And the joke of the day is, have you ever eaten a clock? Okay.